plane, which of course you know is just the axes. On that Cartesian plane, draw the following lines. They do not need to be different colors, just draw them. They don't even need to be close to parallel. Just draw two lines like that. Put a dot at every x and y intercept. Just put a dot. If you don't know what an x and y intercept is, you can't put any dots. But all of you should be able to put a dot, because even if you do not know the mathematical definition of an x and y intercept, you should be able to piece together from the English words. How many dots need to be on the page right now? 4. Excellent. Where are they? There, 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 and there. Correct? Good. These two are what? Y. Because that's where the line crosses the x-axis. Which means these two are what? Y-intercepts. Yay! Now, let's start with that very definition. An x-intercept is any time a graphed line. Now, please notice I did not say straight line. Anytime a graphed line crosses the x-axis, which automatically means what is the y-intercept? A graphed line So now, without going any further, and don't draw this, how many x-intercepts does that red function have? 3. How many y-intercepts does that red function have? 1. Everybody good? All right, so that is the in words definition. Yeah? All right, now let's talk about mathematical definitions. That point right there, since it's on the graph, must have 2 coordinates, correct? And those coordinates must be x comma y, correct? Which of those 2 coordinates, x or y, is unknown right there? X. The x is unknown because you have no idea how far I have gone this way. What is the y value? 0. So that is x comma 0. Where is the other x-intercept? The other highlighted dot. What are its coordinates? X comma 0. If something happens twice in math, how often does it happen in math? Every single time. So an x-intercept must have what coordinates? X comma 0. Always. When? What if it's a leap year and it's February 29th? Still x comma 0. What if an asteroid hits the planet and 97% of all life on the planet is destroyed? Then what? Then the last 3% that are doing math 10 are still going to write x comma 0. Do you understand? When?
I think they got better things to worry about than math at that point.
They will.
They won't die.
They will have better things to worry about than math at that point. But, Luke, a great many people have a great many things that they should be worried about that they don't bother worrying about because they're worrying about things that don't matter. Right? Exactly. I didn't say a question. I said that there are a great many people worrying about a great many things that they shouldn't be worrying about because they have nothing to worry about. Do you have food?
Yeah.
Do you have clothes?
Yeah.
Do you have shelter?
Yes.
Are you being physically, mentally, spiritually, or any other kind of abused right now?
No.
Then what do you have to worry about?
Nothing.
Exactly. Are you worried about things?
Yes.
There you go.
But not related to that.
There you
related
go.
To school.
That was my point. There are people getting up making speeches about whether or not I should be allowed to say the earth is flat. That's the things they worry about when they shouldn't be. Okay? Okay. The green dots are what? Y-intercepts. What is the no? 0, comma, y. What are their coordinates? 0, comma, y. Because you have no idea how far up and down I have gone, but you know that is 0 on the x-axis. And this guy is 0, comma, y. So what does that make this coordinate? Everybody good? Now, if I have x comma 0 and 0 comma y, then do I not have an x and or a y value at any given moment? Yes. Now, let us apply that situation, cabbages, to this situation. F of x equals 2x plus 3. And I want to determine the x and the y intercepts of that. What do I know every single x-intercept is? Every single one in the entirety of the universe is x comma 0. What is every single y-intercept in the entirety of the universe? 0 comma y. What letter do you see right there? What letter do you see right there? X. So, what letter does that 0 represent? Y. What letter does f of x represent? Y. So this is 0. Darn it, it's supposed to be in red because I'm working in red. 0 equals 2 what? X plus 3. Is this ever something we want to see in math class? No, we want to know what x is. How do I do that? Minus 3, minus 3. Negative 3 equals 2x. Then what? Divide by 2. X equals negative 3 halves. Right? Everybody with me? If x equals that, and that equals x, then what can I write there? Negative 3 over 2. So what then is my x-intercept? Come on, you guys. You followed this all the way along. Put it together. Negative 3 halves, comma, 0. That is the point on the graph. Now, I'm not going to put that on the graph right now. Give me one reason why. It's a fraction, and it's hard to graph fractions if I leave this as 1, 2, 3. So I'm not going to put it on the graph right now. We are going to wait. And there's a reason for that. You could simplify it to negative 1.5. It's the same thing. What do I have there? 0. What letter does it represent? X. What do I have there? What does it represent in the function? Fx. So, that means y equals 2 times what?
Whatever the x is.
Which is? Go.
Okay, we're doing a grad versus teachers tug of war, so we're wondering if you're interested.
Why are you even wasting the time? We're going to destroy them.
Get out.
Like, honestly, why would you even... I have a chance to put a bunch of 18-year-olds in their place? Sign me up.
Close the door behind you.
All right. What's 2 times 0? Y equals 3. If y equals 3, what does that y equal? 3. So what is the y-intercept? 0, 3. Now I can go over to my graph. 0, 3, no problem. I can put that on the graph, easy peasy lemon squeezy. But this one is negative 1.5. That makes it a pain. So what I like to do for fractions, when I come to a graph, is I change the scale. If I make this 1, then what is that line? 0.5. So that would mean this would be 1. This would be 2. Where would negative 3 halves be? Right there. Is everybody good? Does everybody understand what I did there?
Yep.
Now, how does that affect my y-axis? Question 1. Question 2, does it have to affect my y-axis?
No.
No, it does not. I can keep this scale because 1, 2, there's 1, 3, 4, there's 2, 5, 6, there's 3. It fits on the graph, so I can keep the same scale. Does everybody understand? So I'm going to do so. My y-intercept is 3. Once I have those 2 points, I can connect the line. Is everybody good? Everyone's good? Now the reason I'm doing this now, when you have a test on Wednesday, is because as you can quite plainly see, this is very helpful in graphing functions. What is the domain and range of that function? How far will it go in the x direction and the y direction? It goes on forever. In which direction? Every direction. So it is, what is the domain? X is a set of what?
Every real number.
Real numbers. What's y?
Every real number.
And then.
What is some fancy little
Everybody good?
Europe?
Everybody good? Everybody can find intercepts? Great. Turn the page over and do it. Go. Everybody's done, yeah?
Yeah.
Everybody has a dot at 0, 4, and or 4 is 0 and 0 negative 2, yeah? Everyone is good. Yes?
Hold on, I'm kind of there. Got the x equals 4, but the y is not.
Everyone is good?
Yep.
All right. Let's look at a couple of things in the two things we did.
Alright.
So, it has a line, right? Yeah? Now, since it is a linear function, that means that line's going to go in the same way forever in the same pattern, right? So, to get from here to here, I had to make changes to both x and y, didn't I? Right? I went up on the y and that way on the x. Where's the next dot going to be? Up that far and then that far over to create my stairway, yeah? Okay. We call that the rate of change because we always use it for things like kilometers per hour and things like that, right? Now, that's called the slope, which you already know from science, right? Does this one have a rate of change?
Yeah.
Of course it does. I went up 2 and that way 4. So where's the next dot going to be?
2.
Up 2 and that way 4. And look, there it is. Everybody cool?
How did you find the y that one?
I substituted in 0 for x. 1/2 of 0 is 0 minus 2. 0 minus 2. Y equals negative 2. All right. Now, the next thing I want to point out. What do you notice about the things I am highlighting in blue? Everybody see? And now? What do you see? The y-intercept is in the equation. And that makes sense because the y-intercept is where x is 0, right? And when x is 0, that's going to drop out. Everybody good? That, ladies and gentlemen, is this. Y and x are coordinates. Just from the graph of an x value and a y value. B, we have just proven, is the y-intercept. So what's the only letter in there that we haven't talked about? M. M equals the rate of change. All right? And my rate of change we know is something like a speed, yes? So, in math, a rate can be one of two things. What are the only two things it can be? Positive or negative. So that must mean our slope can be positive or negative. But, Mr. Myers, how can a slope be negative? I'm about to show you. So, here, please label point A. Here, please label point B. I am not allowed to pretend. No, I'm not allowed to pretend. No. Strike the I'm not allowed part. Pretend like I need to get from A to B, but I only have an Etch-a-Sketch.
What?
I know, right? I do this on purpose. Etch-a-Sketch is that stupid old drawing toy with the two lines that you shake. Yes, I know, it's awesome. I can draw Canada with it. And with provincial borders. True story. I do not have an Etch-a-Sketch right now. Anyways, an Etch-a-Sketch has two dials. One dial moves the line on the x-axis. The other dial moves the line on the y-axis. To make a diagonal line, you must turn them. If you turn them at exactly the same rate, what line will you get? A straight diagonal line with a slope of 1. Because for every one turn to the right, you turn one turn on the other dial and you will get a perfect line. You cannot make that happen. The line is always squiggly. The only lines you can make perfectly straight in the Etch-a-Sketch are up and down and side to side. So if I was going to use an Etch-a-Sketch to draw from A to B, I could only go up and down and side to side, correct? So if I went up first, in math, what values are associated with up? Positive values. Then I would have to turn what direction? Right to get to B. And what values are associated with right? Positive. So if the rate of change is, we always use, it's always dV over IV, correct? So this rate of change would be a positive value divided by a positive value. Agreed? Which means this is a positive slope. Does everybody understand? Now, everybody says, oh, Mr. Myers, how can it still be positive if you go the other way? If I go from B to A, I have to go downwards, correct? Which is what? Negative. And then I have to go this way, correct? Which is what? Negative, which means I have a negative divided by a negative. Two negatives make a positive. Everybody got it?
Also, that's not a negative slope.
Now, let's look at C to D. How would I get from C to D? So from C, I got to go to the right, which is what? Positive. Then what? Down, which is what? Negative. So I would have a negative dV divided by a positive IV. That gets me what? A negative slope. Mr. Myers, what if we go the other way? Okay. Down is what direction? Negative. Right is what direction? So I have a negative divided by a positive, which still gets me a negative slope. Does everyone understand? All right, we have drawn two lines today on graphs. Are they positive or negatively sloped? They are both positively sloped. Excellent. What are their slopes?
This one is 4 and 1 or 2. 4, negative 2, and then isn't it y on top? Rise over rise? Yeah. So
dV over IV. So what's my dV here? 2. What's my IV? Are they both positive? 2 divided by 4 is what? 1/2. Notice what I'm highlighting. What about here? I went up 1, 2, 3, 1, 2, 3, 4, 5, 6. But that's not really 6, it was 3, right? And I went this far, how far? No.
negative 1.5.
That's 1.5, right? So dV3 divided by 1.5 is what? 2. What do you notice?
So the rate of change is always the end. Yeah, see, there you go. That's what you taught us.
Picking up what I'm putting down?
Taught us that. You're so good.
All right. So now we can do some more talking down here. Slope we know is m, but what is it also? It's also the rate of change. It's also the rise over the run. It's also the change in dv over the change in iv. It's also the change in y over the change in x. Is everybody good? All of those things are slope. And slopes can be positive, which look like that, negative, which look like that, but then there's two other kinds of lines we can draw, isn't there? There's a vertical line, which I have right here, E to F. How do I get from E to F? Positive. Divided by what? 0. I didn't go anywhere side to side, did I? Can you divide by 0?
No.
No. So this is what we call undefined. Because it is technically infinite, isn't it? If I were a skier and I were there, I'll make myself a snowboarder, so I only have to draw one board.
You're gonna die.
Is that skiing or is that falling?
You're gonna die.
That is falling. Because that slope is infinite. We wouldn't say you skied down that slope, we would say you fell down that cliff. Now, being the intelligent people that you are, G to H. Do I go up and down at all?
No, man.
0. Over, how far do I go this way? Positive. What's 0 divided by anything? 0. So that is a 0 slope. Again, use the skier.
He's cross country skiing.
If I'm a snowboarder and I'm on a 0 slope, am I going anywhere? Only if I look like an idiot. Like all the snowboarders look like when they get to where it's flat. Or they do that weird skateboardy thing with their foot and they destroy their knees. And then they complain when they're old.
It's like a
Smart skiers carry poles. We never have to stop. We push. So I can have a positive slope, a negative slope, or
Up and down.
undefined because it's infinite, or flat, which is 0. Is everybody cool? Now I remind you, slope is all these things, and it lives, right there in this form. Turn the page over. Now, tell me, are all of those 4 lines in that form? Yes, you do. Just look at it. Is the output isolated in all of them?
No.
Who just said no?
Wait. Negative X. There's no
Output.
output.
Is the output isolated in all of them? Yes. So this part is good. Does X have a coefficient in all of them?
No. That's what I thought you were asking.
It does. It just has coefficients we don't write. What are they? 1. So there's coefficient. Is there a constant in all of them?
yeah.
Because what could I write there?
1.
Plus 0.
Alright.
So, should I be able to draw all of these right away? Yes. Which of these points that I am highlighting is a spot on the graph? Yellow or blue? Blue. What is that spot on the graph? It's the y-intercept. In this case, it is -4. Where is -4? 1, 2, 3, 4. There's my first dot. How do I know where my next dot is? I know that when I'm in this form, that is my slope, yes? And 2 is really 2 over 1, isn't it? And it's also my slope, which is also my rise over run, correct? How do I do a rise of +2? I go up 1, 2. 2. How do I do a run of +1? I go, don't say over. I go where? Right. 1. Since it's a line, where will the next dot be? Up 2 over 1. And the next dot? Up 2 over 1. What about going to the left? Down 2 left 1. Then where? Down 2 left 1. And it makes this nice line. Is everybody Gouda? Great. Graph the next 3. I'm confused as to why you're finding it confusion. Which of those two numbers, the -1 or the +1, is a point on the graph? The +1, because it's the y-intercept. Now what's my slope?
We have -1.
-1 for a slope. How do I get a negative rise?
Go down.
Go down 1. How do I get a positive run? Go right 1. Or, back to the starting point, what's the other way I could go? Up 1 and left 1. And that makes this line. Everybody Gouda? Great. Where do I go for C? I go up to 5. 1, 2, 3, 4, 5. And then where do I put my next dot? Down 1 and left 3? Right 3. Or up 1 and left 3. And there's that line. And finally, the green line. There is no y-intercept written. What is the number that represents 0? What is the number that represents nothing? 0. What's my slope? 1. Positive or -1? So up 1 and right 1. Or down 1 and left 1. There's that line. Now, what do you notice? What word would you use to compare the black slope to the green slope to the blue slope? Bigger? Steeper. Right? The bigger the number, the steeper the slope, which makes sense because a vertical one is an infinite slope, right? And infinity is the biggest number you can have. Everybody with me? All right. That makes the guy happy. Now, quick practice from last unit. Which of those lines, blue, green, red, or black, is the function f? That is the black line, correct?
Yep.
Okay. Since it's graphed, could we do this on the graph? We could, couldn't we? F of 2, is that an x or a y value? That's an x value. So when I go to f of 2, what's the y value that goes with that? 0.
Oh, are we not looking at the equation? Alright.
Is everybody cool? On the graph, I go to x equals 2 and find the y value. On the graph. How do I do it algebraically? The f of x equals 2x minus 4. How do I do that algebraically? What do I write instead of f of x? F of 2. Which means what do I write here instead of 2? Or instead of x? Just did it again. What is 2 times 2? What's 4 minus 4? 0. And we knew from the graph that it was going to be 0. Is everybody good? Okay. What color line is B?
Blue.
It's the blue line. Which means on the graph, I go to where?
3 on x,
X equals 3
which is
and find y. What is it?
negative.
When x equals 3, 1, 2, 3, what's y?
Oh, there you go, that one. I went the wrong line.
1, 2, 3, 4. Yes? How do I do that algebraically? The h of 3 and the h function was negative 1/3 x plus 5, correct? What goes in for x now? 3. Negative 1/3 times 3 plus 5. What happens to the 3's? Cancel. Negative 1 plus 5 is 4, which we knew was the right answer. Is everybody good? Great. What color is the g function? Red. I want now. How do I do this on the graph? Where do I go?
Wherever the g of x equals 4.
So it's at y or x?
Y.
Go to y equals 4 and find x. Do it.
I found it.
And the other option, g of x equals negative x plus 1, is it?
Yep.
Where does the 4 go now?
X. Oh no, y.
Where does the 4 go now? 4 equals negative x plus 1. 3 equals negative x. What does x equal? Negative 3. And you knew that from the graph because you went up to because you went up to 1, 2, 3, 4 and out 1, 2, 3, and there it was. And finally, when f of x is negative 1, I'm back to the black one. I go to y equals negative 1 and find x. All of you should do that. And then I can also do it algebraically. Negative 1, and I go out 1.5. There it is. Is everybody good? You can all do this graphically and algebraically. You can all find a slope now. Everyone? All right. We're going to continue on, but this page is your slope practice. Page 213. and 214. Is everybody good? All right. Please flip to 215 because I'm doubling up on you today because they're the same thing. Why am I doubling up? What is the word that was in both? What did we end the last lesson with? Slope. What are we beginning this section with? Slope. How important is the concept of slope? Very. What are all the things slope equals? You can flip back in your notes if you need to. Tell me anything slope equals. Rise over run. Anything else? Change in y over change in x. Anything else? Change in dv over change in iv. Anything else? Rate of change. Brilliant. And I just yelled all those things at you. Good job. Now, in each section, draw the appropriate line. So I need the E line in this quadrant, the F line in this quadrant, the G and the H. Go. I need a line with that slope in the E quadrant. A line with that slope in the F quadrant. A line with that slope in the G quadrant. And a line with that slope in the H quadrant. Why am I not telling you where to start? I have my reasons. Go. Yes. Where do I go for that? Right 2 and up 1. When the line is on the graph, how do I find the slope? How do I find the slope when the line is on the graph? What do I do? We've just done it 5 times. What do I do? Count. Rise how far? 1, 2, 3, 4. Correct? Positive. Run how far? How far? 7. So what's the slope? What's the slope? 4 over 7. Is everybody cool with that? Great. Now, what do I do here? I'm going to do that one in a red line. Where do I go? Down 1, 2, 3, 4. And up 1, 2, 3. There's my line. What's my rise? 7 over what? Which is undefined. Can everybody find the slope if I give it to you on a graph? Great. Tell me the slope of this green line. Just from looking at it. If I need to zoom in more, I can. -3 over +5, giving me a slope of -3/5. Can everybody find the slope on a graph? Going once, going twice, going thrice. Every single one of you can count. Yes? Good. Turn the page over. What is different about K and L? What's missing? That I had in I and J. There's a graph. There's no graph. But you people are smart people, yes? You know that slope equals rise over run, right? And you know it's the change in y divided by the change in x, right? What math finds me the change in things? Subtraction, right? Or addition, right? So this must be the difference in y's, and this must be what? The difference in x's. But if I write it this way, what's y minus y? 0. And what's x minus x? 0. 0 over 0 is nothing, right? So I can't write it this way. So I must write it this way. 2, 1, 2, 1. To differentiate between the x's and the y's. Now, how many y's do you see written right there? 2. How many y's do you see there? 2. How many x's do you see there? 2. How many x's do you see there? 2. Everybody know how to do it? That should have been enough. Which of these is y2? Don't say it out loud. You decide. Write y2 above one of these y's. Everybody do it. I want to see 28 pencils moving. I know. And once you have decided on which one is y2, does that automatically let you know which one is y1? It's the other one, correct? Okay. Once you know y2 and y1, do you automatically know x2 and x1? Which partner does x2 go with? y2 or y1? y2. So every one of you has done one of these two things. You have either written y2 and y1, or you have written y2 and y1. Correct? If you are a member of the red group, what am I writing right here? x2. 2 with 2. And what am I writing right here? x1. If you're a member of the purple group, what are you writing here? x2. And what are you writing here? x1. Right? Now, whichever group you belong to, fill this in. I'm going to do both. If I'm the red group, it's 1 minus 7 over -6 minus 2. Correct? If I'm a purple group, it is 7 minus 1 over 2 minus -6. What is 1 minus 7? -6. What is -6 minus 2? -8. Two negatives make what? 6/8. And 6/8, we would never write that. What would we write? 3/4. If I'm working purple, what's 7 minus 1? 6. What's 2 minus -6? 8. Would I ever write that? What do you see? They're both the same. Does it matter which one is x1 and x2? Who decides? You do. What's the only thing that matters? That you match the 2 with the 2 and the 1 with the 1. So all of you now should be able to do this slope. Go. It should take about 5 seconds. I'll start counting now. 5, 4, 3, 2, 1, 0. Who has a slope for me? 15 minus 4 is 11. -5 minus -1 is -4. There's your slope. Could everybody do it? Did you have to do it in 5 seconds? No, of course not. I'm doing that in 5 seconds because I have found slope between 2 points about 100 million times. Do I need to think about it anymore? No. Why do I not need to think about it anymore? Because I've done it 100 million times. If you need to think about it, what is the only reason you need to think about it? Because you haven't practiced. What would be the way to make sure you don't need to practice? Practice. Are these on the graph? Are A, B, C, and D on the graph? Excellent. Which means on the slope, all we need to do is count, correct? Right? Because they're on the graph. So here I go. I'm going to count from that point to that point. Why is that a bad idea? Cuz is never the answer. Cuz is what you say when somebody asks you a why question and you don't have an answer. Pardon me? The line is, it's long, but the slope's going to be the same all the way up, isn't it? So why shouldn't I start at each end? Slope is rise over run. So rise over run. Why is what I am doing a bad idea? It's not on a what? It's not on a point, is it, Green? Do you know what that point is right there? No. So can you count, rise, and run from it? No. So I'm going to start sliding down the line. You tell me when a good time to stop would be. Okay. Now, still can't do rise and run because I don't know how far that is, do I? So I need another point. I'm going to start sliding to the right. You tell me when to stop. I hear some yeses and some no's, so I'm going to keep going until somebody else says yes.
Yes.
And I'm going to keep going until somebody gives me a yes that's correct. So, some people said yes here. If you stopped here, what is the slope? How far is that? 3. How far is that? 1. So what's the slope? What? Yes. -3, because -3 over -1. If I stopped here, I went up 1, 2, 3, 4, and over 1. Oh. So what's this slope? Different. That can't be. It's not. So, what is the better thing to do? Do the whole thing, the furthest apart you can get. Now I'm up 7, and I'm this way, -2. Which is 3.5, isn't it? Exactly between 3 and 4. Everybody understand? Now, let's pretend this was a test. And half the class showed me that and said the slope was 3. Right? The other half the class showed me that and said the slope was 4. One person in the whole class showed me that and told me it was 7 over 2. Who gets the best mark?
7 over 2 kid.
7 over 2. Who's right?
7 over 2 kid.
No.
No one is.
Who's right? Everyone, because they all showed me they understood rise over run. Who gets the 4 out of 4? Green, pink, or blue? Green. Does everybody understand? Now, knowing what you know, try to do B. And I'm going to use green again because I used that for the right one. Give me some slopes for B when you have a few. As soon as you think you have a slope, tell me what you think it is. I've got a 3/7. It's a positive slope. Could very well be.
-1/2. I simplified it from -3/6. But the whole thing's negative.
I got a 3/7.
We got another 3/7.
Oh, it is 7.
We got another 3/7.
I counted wrong.
We got lots of 3/7s, yeah? So, if I started there, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Does it show me you understand rise and run? Yeah? Does it work out exactly? I would go down to there. The biggest one I can get. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5/11. Now, three divided by 7. 5 divided by 11. Are they close enough? Everybody get the marks? Everybody understand? Good. Now, all of you, draw me a triangle with 3 positive slopes. Go slow, because you're going to screw it up unless you're careful. You get 1 try. So stop and think about it before you draw.
I got it. Okay, I tried. That's a diamond. What the heck is that?
Not a triangle. All 3 must be positive. To start this triangle, I must start at a point, yes? Somebody give me a point.
0, 0.
Okay.
I like it.
Now, how do I make a positive slope from there? I have to go up in what direction? Up and right. Is that okay?
Yeah.
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 That.
No.
That. 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 All of them are okay, correct? Guess we'll see you tomorrow.